Morning, everyone. Hopefully you guys know who I am by now. My name is Dane Ungerite. I'm the TA for this class for this particular semester. Dr. Greenslet, as you should already know from the announcement, she's currently overseas in Paris for a conference, so I'll be covering today's lecture as well as Friday's. So the plan, I believe this was also in the announcement for today and Friday, is today the goal is to hopefully go over once again and clear up any sort of questions or confusion you may have on the project. So I'm just going to go over the slide that she already prepared for us, go over what we're expecting for the project, as well as the intermediate checkpoint assignments that we have for the rest of the semester. And that shouldn't take up the whole lecture period. So either I could transition into Friday's material in MAF, or what I was thinking might be a better idea, and some of you might be interested, is potentially talking about your midterm exam, because that is, I believe, exactly 2 weeks from today. So it's, I'm sure some of you guys may have some questions on what those questions will look like. To be fully honest with you guys, the exam isn't written yet, but I've taken this class before, so I know what the exam should look like. So I can talk to you a little bit about how to prepare and answer any questions you may have, both on the project and potentially the midterm. All right, so with that in mind, let's get started. So as you're already aware, for this project, you have to write a report on a non-traditional manufacturing process or some sort of topic related to that. Most of you will probably have already selected, well, all of you have selected a topic, and most of you have already selected a topic that is covered directly in this class. So I know a lot of people, for whatever reason this semester, a lot of people really want to talk about water jet machining. That seems to be like the most popular topic. A lot of people also still want to talk about EDM. That's always very common. So some sort of process that's usually in the course, but you don't have to limit yourself to that. For example, when I took this class, my group, we did our report on electrohydraulic forming, which isn't covered in the class. So as long as it's some form of non-traditional manufacturing process, which hopefully you should know what defines non-traditional manufacturing from that first homework question, as well as from Dr. Green's lecture. It's any process that essentially uses an energy source to deform or remove material to form your part. It's usually an energy-based method that typically doesn't rely on a hardened tool to chip away and remove material. So, EDM, we use electrical energy, there are chemical processes, et cetera, thermal, lasers. So anything that's related to that is fair game. I know a lot of you, we've already approved everyone's topics. I should mention that I'm not going to encourage anyone to necessarily change their topic going forward, but you are allowed to, and I'd say even encouraged to, either expand or maybe contract in some cases the scope of your paper. There is a strict 6-page limit with this report, so as you go through and write your report, you might find that, okay, what I originally planned on talking about with this process, I don't think there's enough material to get to 6 pages. In that case, you can feel free to broaden the scope a little bit, or in some cases, like there are some people who want to sort of compare like 3 or 4 different processes, and to talk about all that in 6 pages could be a little tight, because just explaining what the processes are, that might end up taking like half the report right there. So in cases like that, feel free to contract your report a little bit. All right, so she starts off right here with this slide with an example outline of your report, which your outlines, hopefully everyone here has already turned in their outline because that was due before the start of class today. So just an example, you're going to start off with the template, your title and your name. It's not posted here, but there's an abstract that'll go immediately below that. I recommend that, although you've already written an abstract, you'll probably have to rewrite it before your final submission. So once you've written the full text and body of your report, go back and rewrite and adjust your abstract to better reflect the body of work. After that, you'll have an introduction section where you usually just introduce the process. An example here, processing principle and processing equipment. I want to make a quick note on processing principle. Depending on what your topic is and what process you're discussing, you may not necessarily need an entire section dedicated to processing principle, in my opinion. It depends really on what the process is and how quickly, like in your abstract, most people have like a quick 1-sentence summary of what that process is. Now, if you think that like the process is a relatively simple process and the principle behind it can be explained in like a single paragraph, don't have a section that's just a single paragraph. So if you want to maybe combine that into a different section, that could be in your introduction, or for example, you can combine that with your equipment section, because as you go through the different parts and the equipment inside of your process that are used within it, you're sort of going through and explaining how the process works as well. So if you do those two sort of simultaneously, you can combine those two sections together. So the sample outline that's included in this PowerPoint is not rigid. You are not required to follow this. This is just an example of some potential sections and stuff that you can talk about in your report. Then there's a results section where you talk about the results of your processes and what it can achieve. That can be like applications. It can be like advantages and disadvantages, although I think that might be more of a conclusions section. So then obviously you end with your conclusions, and then you have to have your references. Your references you should hopefully by now also have at least 10 scholarly sources for your references. That was also in the due date in the assignment that was due today. Again, I discussed, I'll go over it again today, what we qualify as a scholarly source. But again, your 10 sources that you have for this assignment, we encourage you to use those in your final report, but also don't feel like you're restricted to the references that you submitted today. If you go out and you feel like you need more resources, more references for your paper, feel free to go out and grab some more. We just require a minimum of 10 scholarly sources. And you can also include some less scholarly sources like a company website or something, so long as you deem it like a trustworthy source, but it just won't count towards the 10. Okay, so although I did say that template was sort of an example and you're not required to do it, I do think everyone here should have an introduction section. So what should you include in that? The two most important things to include in your introduction are, one, background, so background on the topic. This is sort of like the preface to your paper. Why is this important? What's so interesting about this? Anything going on currently that's led you to want to discuss and write this paper. And then lastly, the most important thing, and I left lots of comments on this on abstracts that were submitted already. You need to have a clear objective statement in your report. And your objective statement is simply, what is the reason for writing this report? And no, the reason should not be, oh, because Dr. Greensley told me to. No, because this is for a project assignment and I'm trying to get a grade. It's what, if treat this as like you're writing an actual technical paper that you're trying to publish. Why should the publisher want to publish this? What is the purpose and the intent of this paper? What are you trying to communicate to your audience? So that's what you need to do. That could be to detail the state of a current technology and its current state. It could be to summarize the literature on a particular topic with specifics to certain process, or it could be to compare the fundamental differences between two or more different processes. So your introduction as well as your abstract should have a clear objective statement on what is the intent and purpose of your paper. So and she asks here, so how are you going to approach this topic? What specifically on this topic are you going to talk about? So are you talking about the advantages of water jet machining? Are you talking about applications of water jet machining, or are you maybe talking about specifically aerospace applications of water jet machining, or automotive applications? So a clear, concise topic statement, an objective for your paper. All right, processing principle. Now, like I said before, I don't think you necessarily need to have a dedicated section to this, but you need to at least talk about this. This is important. You shouldn't just assume that whatever manufacturing process that you're talking about, that the reader knows what it is. Especially for this particular class, one of the main reasons for this class is for this project is to evaluate your understanding of that topic that you chose and make sure that you did the research. So part of that is we want to make sure that we can see that you understand how this process works. So you're going to want to have a written description of how the process works in detail. And I'm not going to say it's necessarily required, but it's highly, highly, highly encouraged that you have a figure to demonstrate that processing principle. Often you can probably find a paper that has a diagram of it already if you want to reuse that. So if you want to make your own, that's also fair game. But obviously, if you're going to pull a figure somewhere from the internet from another paper, you obviously need to have a reference and a citation for that. So no plagiarism for your report. Okay, now processing equipment. This is also, I think, another pretty important fundamental topic, area that I think probably should be discussed in some capacity in your report. So that kind of goes hand in hand with your processing principle. So you know fundamentally what it does, but I think we also want to make sure that you understand how it does it. So what pieces of equipment are used to it? What role and what function does each piece of equipment do in the fundamental flow of the process? So also how it's used, how it's operated. Optional, not going to say this in a segment required, but if you want to go into a little more detail, you can talk about like what sort of like options are there for certain pieces of equipment. Like are there, if you want to talk about for water jet machining as an example, what sort of like nozzle characteristics? Are there different types of nozzles, different sizes? What are the advantages and disadvantages of those different types of equipment? If you want to go for EDM, any sort of differences in your diode geometry, in the material of your diodes. So how does that material and the geometry affect your process? So if you want to go into a little more detail on that, that's also not a bad idea. But again, obviously, figures would also be very helpful too. It could be the same figure of your overall processing diagram, and you have labeled out your different pieces of equipment. Or you can have like pictures of the actual equipment itself. So like I said, if you want to talk about nozzle diameters on a water jet machine, you could have maybe a figure of different nozzles, different sizes, different shapes maybe even. Just once again, remember that to cite your sources. If I recall correctly, I don't think Dr. Greenslet gave you guys a required format for your citations. And I don't think we're going to necessarily enforce like a strict format for your citations. What we encourage you to do is look at one of your journal papers that you reference, and then just sort of go to their references section and then mimic that style. So you need to have your authors, you need to have the title of your work, of the paper title or whatever, where it was published. So like Journal of Medical Devices or whatever the title of the journal is, volume and issue, the date it was published, if it's an online source, the date you accessed that source. I'll go over a sample, I think, towards the end of this portion of the lecture, just to make it clear. But common formats that I would encourage would be IEEE or ASME. Those are two very common engineering standards for citations. But if you look at one of your technical journal papers that you cite, you can just look at the reference section and just try to mimic that and be consistent throughout your entire reference section. Don't use a different template and a different format for every reference. Don't jump around. A lot of people will just access an article and then they'll go to the Cite Me button and then they'll just copy and paste that citation. But that's, if you do that for multiple different sources, they have their own sort of different way of generating citations. So we'll get some inconsistencies there. So the big thing is try to make it consistent. And again, we don't necessarily have a rigid format, so you don't have to necessarily follow like the strict guidelines. We're going to make sure that you have the most important details. Like you need to have the authors. That's the biggest one. The authors, the title, the publisher, where it was published, and then probably the date it was published. Those are probably the most important parts. All right, got a little ahead of myself there. Let's go back into the body of the report. So the results section or application. So this isn't necessarily like a research paper. It's not like primary research. It's not like, okay, here's my methodologies and here's my results. So a lot of people kind of get confused when we say results. What exactly is meant by like a results section? And that's mostly like examples like, okay, so we've talked about what the process is and how it works. And now this is the part where you show like that process in action. So what can we accomplish with this process that you've already described in your paper? So this is a great place to put applications or examples of how it was used. It's a good place to also maybe talk about some effects that have come from this process. If you want to maybe talk about some processes that offshoot from this process as well, you can maybe talk a little bit about that. And then you have advantages and disadvantages. I think that's something that should be, is a great thing to discuss and should probably be discussed in some capacity in your report, because that's a big thing that we look for in this class. But again, that could be more of a discussion section, I think. It could be, you can make a case, a lot of people like to sort of combine their results and discussions together. So if you want to throw it in with your results as well, I think that would be fine too. Okay, so now we just go over, make sure I'm not missing anything on these slides. So results of the process with examples, applications. Also talking about what fields tend to use that process is a good point to mention up. So is it highly used, is it popular in the automotive industry? Is it popular in aerospace? Is it used in the food processing industry? What sort of where can we find this process used, in common like applications of it? So that's a few industrial applications, and then obviously figures. A picture's worth 1,000 words. So if you want to talk about, if you're talking about like AFM being used for turbine machinery. If you want to show us a picture of like an actual turbine that was machined, or maybe if you have some sort of like a diagram showing specifically that process machining, or maybe like for example, if you're machining an external part with the AFM, we've talked about how you need some sort of like external shell to sort of couple and complete to push your slurry through. So if you want to maybe show a picture of what that coupling or that shell piece would look like, that would be a good figure to have. Keep in mind that figures are often encouraged, but there is still a 6-page limit. So try not to go too crazy with your figures. Try and make sure that your figures are actually contributing something of value to your paper. So like a processing diagram is super helpful, and I really would encourage that. Equipment is another good place. And if you're talking about specific applications, maybe one picture of each application. What you could do is, if you're confined for space, is say you're talking about like 4 different applications in your paper. What you could do, instead of doing 4 different figures of that application, you can bundle them all together in a single figure and just have like part A, B, and C. So if you can do like a sort of window tile shape for your figures, and that might help you save some space. So just some food for thought there. Obviously, once again, cite all your pictures. And I believe you need to include captions for all your figures too, so don't forget that. All right, then lastly, you have your conclusions. Your conclusions where you talk about your summary of your findings of your entire report. And a good rule of thumb is that it should somewhat mirror your introduction. Especially, so if you're talking about, remember I talked earlier about the objective statement. So you talked about what is the clear goal for this paper, what were you trying to accomplish. In the conclusion section, you should go back and reference that objective and say how it was or was not accomplished. Given that this is like usually some form of a literature review that you'd want to try and summarize. I don't expect anyone to not accomplish their objective statement. That's usually something more for actual like specific research reports where you're trying something new. But go back and make sure you make a clear reference to your objective statement. Talk about how you accomplished your goals, what were your findings, and give an overall quick summary of your report findings. Okay. Here's a good source here. So this is the ASME referencing guide. This is what I would recommend you use. Let me scroll down. Oh, okay, so the link wasn't direct. Honestly, I think it's probably faster if I just Google it. It's a little slow today. There we go. So this is specifically how ASME recommends you create your citations. Again, I don't think she puts a requirement. Again, if I'm wrong and Dr. Greenslet gave a format out, go off of what Dr. Greenslet says, not what the TA says. That's always just a good rule of thumb. Go off of what the instructor says, not the TA. She'll be the one ultimately reading your final paper, not me. I'm just there to help guide you along the way and give you advice. Okay, so we're there. So here's a quick little example. Obviously, your reference style will depend on the source type, so whether it's a journal paper, whether it's a book. So the type of source that it is will affect your style. ASME is loosely based off of Chicago. It's not exactly, there are some differences, but it's loosely based off the Chicago style. So here's some examples real quick of citing a journal paper article. So you're going to have in brackets the number of your sources in the order in which they appear. So the first source that you reference will have the number 1, and it'll just go down sequentially in order. Yeah, and then when it comes to in-text citations, you want to include that number in the bracket inside of your sentence where you reference that source in the body of your paper. I think it's also generally a rule of thumb not to include references in your abstract. So try to avoid that, but in your introduction, definitely include them. Any part of your body paper, be sure to include your references. So you have your number first in the order in which it appeared. So at the end of your paper, you'll have a list of them all, 1 through at least 10, might be 20 for some people, it'll vary. And then you have first your author name first, so they get listed. So if you have one author, and as the case with this first paper, it goes last name, comma, first initial of the first name with a period, comma. If you have multiple authors, you would go through and list them all like you see in this bottom one here. So you got 1, 2, 3, 4 authors for this paper, and you list them that way. So you go through and you list all your authors, last name, comma, first and middle initial, comma, and then go your other authors as such. Then next they have the date in which that article was published, and then in quotations after that you have the title of the article, and then over here we have this is the journal in which it was published, abbreviated. Again, if you know the technical abbreviation for that journal, we encourage you to use that. But if you don't know it and you want to spell it out, that's fine too. This 3 here, I believe, should be the volume. For this particular source here, you see there's an 18 and then in parentheses a 3. So that's volume 18, issue 3. And then after that, we have the page numbers. And then in some cases, you might have a DOI that you want to include. DOIs are just nice little it's a universal standard sort of that allows you to easily identify an article. I'm a big fan of DOI. I don't think you necessarily have to include it. Well, you definitely don't have to include it because I think some articles might not even have a DOI, but it's increasingly popular today. So odds are there will be some form of DOI if you want to include that. Textbooks. Now, if you're citing in general an entire textbook, use this first one here. That should be your guide. If you're only referencing a particular chapter or a section of your textbook, use the one below that. I think most of the time, most people will probably be referencing this. You'll be just looking at a particular chapter that covers your area of interest. So this is probably the better one to use. Textbooks is if you are basically citing the entire textbook as a reference. Like, oh, I read this entire textbook and I remember this from the textbook. Like if you're citing the entire book, use the first one. If you're citing a specific chapter or a section, I encourage you to use the bottom one. All right, then conference papers or proceedings. That's very similar to journal paper style. So we see here, got author names again, you got the date, the title, the name of the conference. So what you see here, proceedings of and then you have the conference abbreviation. Where the conference or the proceeding took place. This was New Orleans, Louisiana. The dates of the conference, the year, and then there's usually like a paper number associated with that specific paper within the conference. And then you have the page numbers. All right, some other things here. All right, then you have over here some like online source citations. I'll let you go through that yourself. But again, for online sources, like if you're citing a website, if you have a date that it was last published or that a last date modified, you should definitely include that, but not all of your online sources will have that available. So at the very bare minimum, you should include the date at which you last accessed that source. Because if for whatever reason that changes, that kind of helps cover you. So again, you're welcome to include websites, videos, some non-scholarly sources, but just keep in mind they won't count towards your 10. So yeah, this goes through theses, technical reports. Ebooks are a little bit different, but very similar to citing an actual textbook. Over here we have a table of specifically ASME journal paper abbreviations or journal title abbreviations. So if you're citing any of these journals, feel free to abbreviate them, as you can see on the right. All right, and that's just a quick review there of how to cite references using the ASME style. Yeah, so examples of like technical sources, books, technical journals, magazines, encyclopedias are also fair game. Patents are a good source too, particularly with like newer and emergent processes and technologies. So don't hesitate to reference a patent if you'd like. So yeah, so scholarly and technical like publications are kind of the go-to there. So at least 10 of those. Plagiarism, just don't do it. All right, procedure for making the reports. This has already been gone over. So you should already have your 10 sources selected. Hopefully you've read them carefully and gone through them, and you should now hopefully have an outline of your report with the chapters all titled out. So you should have a general idea for the format of your report by now. The next step is going to be to get your figures and your tables lined up. So you have your skeleton laid out and all mapped out for your paper. Now it's a good point in time to start looking for what figures and tables do I want to include in particular sections. So that sort of gives you like a pictorial story of what you want to include in your paper, and that'll help guide your writing. So that's sort of the idea with that. That'll be included in your next sort of checkpoint assignment. So I believe, if I remember correctly, your next assignment is the introduction along with your figures and tables. So for that particular submission, you'll go back into your template. You'll then take your outline that you submitted last time. Feel free again to make adjustments if you change your mind on certain sections you want to include. You'll fill out your outline into your template. Your introduction section, you'll go ahead and you'll fill that out and you'll write that out. And then you'll also go ahead and underneath all of your headings and subheadings, you'll start placing your images, your figures, and your tables into those sections with your captions. Again, not every section is required to have a figure, so don't feel like you have to put something for everything, but in general, I think more often than not, I think every major heading will probably have at least one figure if I had to guess, just as like a decent rule of thumb. But again, keep in mind you have a 6-page limit, so don't go too crazy with figures. All right, so once you have your figures and your tables made and you start writing your introduction, then it's time to actually start writing the actual document. So then you go ahead and you write out and you fill in your report itself. And then once you've written the entire report, it's good to go back and check your introduction and conclusions. I'm also going to add in check your abstract, because when you first write your introduction, you first write your abstract. You have a general idea of how you want and how you plan to write your paper. And as you go through and you write that stuff, things may change. You might need to expand or contract your scope a little bit. So that's after you've written the entire document, go back and check your introduction and your abstract. Make sure that what you said you were going to talk about, you actually talked about. So if there's stuff that you have to remove from it or something that you want to add into that, go ahead and do that. And then once you've checked your introduction, your abstract, go back over to your conclusions and check to make sure that you're still mimicking and you're still following your objective statement. And then also another important thing, make sure that you've cited all of your sources correctly. So it's also a good idea to make sure that you have your citations properly numbered. So you might, as you rewrite and reorganize your paper, you may have thought that this first reference was reference 1, but now you have an earlier reference, and that reference 1 is now reference 2. So try and keep tabs on what reference is for what paper, and try and make sure you keep that numbering in sequential order, in the order in which they appear. So once you've checked through your introduction, your conclusions, your abstract, and your sources are formatted, just make sure that you have a consistent formatting in your report. Try to avoid just dead white space at the end of a page if you can avoid that. Try and make sure that your figures and your tables are as close to or in general, I like to keep them in the corner. Oh, didn't realize this is touchscreen. In the corners of your page, so maybe top left, top right, bottom right, because of your two-column format. That's usually how I like to do it, but you also want to try and keep it as close to the order of reference as possible. So as you're talking about your paper and you say refer to figure 1, you shouldn't say something like, okay, refer to figure 1, and then refer to figure 3, and then refer to figure 2. You should have them in sequential order that way, in the order in which they appear, and the order in which you reference them in your text. So try and make sure that formatting is consistent. Okay, now that about wraps up the report section. For all of you who are here in person, who are on-campus students, not ed students, you have to also make a presentation. For those of you watching at Edge, you can probably skip for the most part this last portion of this part of the lecture. Hopefully I'll still have some time to talk about the exam, so don't skip too far. To start off for your slide, you want to have an outline of your presentation. So what I recommend is you have a title slide, and then your first slide after your title slide is just a quick outline or like a roadmap for your presentation where you just sort of preview what you're going to talk about. So first we're going to talk about the processing principle for this process. Then I'm going to go into detail on the equipment on it. Then I'm going to show you some examples of the application. Then I'm going to give you some advantages and disadvantages. So something like that. So just a brief outline of what you're going to include in your presentation is what I recommend for your first slide. And then you go through, you don't necessarily have to have one slide per section of your report, depending on how your report was structured. You might be able to combine some together. But just keep in mind that, as a good rule of thumb, you should assume that each slide should take roughly 1 minute. So you guys should know already the time limit of that. I don't remember it off the top of my head. I know it was in the syllabus, but make sure that you have roughly one content slide per minute of presentation. Obviously, the title slide, that'll take less than a minute probably. Your outline slide, I think probably your title and your outline should take at most a minute, those two together. But your content slides assume 1 slide per minute. And then another big point that I want to highlight here, do not put too much information on a single slide, especially text. This is a PowerPoint presentation. Who here has ever been to a presentation and you see a slide and it's just a giant wall of 12-point font text? And you just groan. So don't be that person. A picture's worth 1,000 words. Your text and your bullets, they don't have to be complete sentences. In fact, I would encourage you try to not write sentences for your PowerPoints. You should have a title. If you want to talk about a word or a concept, your bullet points and your text on your slide should primarily be there to just remind you of what to talk about. They shouldn't be word for word what you're going to read off. So a big mistake that we commonly see with these presentations is we'll have teams that will basically just stand up right here, face the PowerPoint the entire time just to read off the PowerPoint. That's not good practice. So try to minimize the text on your slides. Pictures, 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 pictures. Lots and lots of pictures. Don't feel you're limited to only pictures and figures that you use in your report. You can add extra pictures to your PowerPoint presentation. You will need references for everything that you include in your PowerPoint. So if you add extra pictures, you will need to make extra references and include that. At the very end, you should have a references slide. you obviously don't need to go over and talk about them, but like, okay, here are my references, the end. So include your references for your PowerPoint, and renumber them too. So like so your figures should be like 1, 2, 3, 4, 5 in your slides, not necessarily lining up exactly 1-to-1 with what is in your report. Because you might not have a reference for everything. You might not reuse all your references from your paper in your presentation. So make sure that when you list out your references on your slides that they match your slides, not your report. Yeah, we don't give you like a template for your PowerPoint just for the Word doc. I know some people have asked if we have to use this specific like PowerPoint file that I'm showing you here. You don't have to. You can make your own. Just make sure it's professional. Style, font, size, just keep it consistent. Make it somewhat aesthetically appealing and clear to read. Don't do any sort of crazy like script font that's like really hard, that looks really cool but it's hard to read. Try to avoid that and keep it professional. And then once again, when you talk about your introduction and you give out like, when you talk about like the objectives in your presentation, make sure that your conclusions mimic your objectives. So if you have like 3 objectives for your report, you should have like 3 bullet points for your conclusion one that directly addresses each of your objectives. All right, and then lastly, this is the evaluation criteria for everything. You have your report, so the length, so make sure you hit that those 6 pages. The technical relevance of your report will be evaluated, your writing clarity, the formatting, making sure that you have valid references in the proper style. Again, highly encourage ASME. You have I showed you where you can access that. It's inside the PowerPoint too. You can also just Google ASME reference style. The timeliness of your submission, late submissions will be penalized. May even be a 0 in this particular case, unless you have like a previous excuse. And the best way to get an excuse and make sure that you're not getting heavily penalized on your submission is to ask for it in advance. Don't email me and Dr. Greenslit the night before the night it's due and be like, hey, I'm not going to finish in time. Can I submit it tomorrow? Plan ahead of time. Presentation. So the length of your presentation, making sure you're not too far over or under time. And then mostly similar to the report, technical relevance, the clarity of your slides, so making sure that your pictures are nice and clear. If you're taking some screenshot of a tiny figure and then you're blowing it up so it's all blurry, that won't look good. You'll get some points off for that. Making sure that it's clear, making sure your slides aren't too wordy, that your slides are submitted on time. Making sure you're not only is your presentation on time, but it's also not clearly you're stalling for time, or that you're rushing to the point where you're trying to just squeeze it in time and you're just rushing in and no one can understand what you're saying. So make sure that you guys are pacing yourselves and you're nice and clear and concise in your presentations. And then after the presentations, you'll all have a Q&A session where your peers will will ask you questions and you'll have to answer them. So you'll be evaluated on your ability to answer the questions from your peers. Hopefully there'll be more students here in the room when you're actually giving your presentations than there are here today. So hopefully it doesn't rain. And then also we do sort of pay attention to making sure that you guys are paying attention to other people's presentations. If we see somebody fall asleep during another presentation, we will dock points for that. So just try and be respectful of your peers and pay attention to their presentations. You all worked hard on this, so show everyone the courtesy you want them to show you. All right, and then lastly, there's a feedback assignment. Your feedback assignments consist of 3 forms that you will submit, and they are a portion of your final grade, so do take them seriously. So the 3 forms are the presentation evaluation form, you have a written report evaluation form, and then you have a peer evaluation. So your peer evaluation is the peer evaluation is only for on-campus students. Ed students do not need to fill that out because they don't work on a team. So this is where you basically grade and score your peers and your group members on how you felt they contributed to the report. So this is your opportunity to anonymously rat out anybody who you felt didn't contribute to your report, or maybe give someone a shout out who you think worked really hard on your report. So that's the intent purpose of that, to make sure that if this is a great report and gets a good grade, if somebody didn't actually contribute to that report and it's like a three-man team and the fourth guy just kind of sat around and did nothing, make sure that they get punished for it. So that's the peer evaluation. The written report evaluation, once everyone has submitted their final drafts, we're going to upload all of your final reports to Canvas in a folder. And then everyone will be responsible to select one report, and then you have to read that entire report and give feedback on it. So you'll have to read somebody else's report and give feedback on that. There's a form on the Canvas page. I'll show you it real quick. So if you go to the forms folder, you'll see here, that's the presentation evaluation form that I'm going to talk about next. Here's your feedback form, and then your performance evaluation. That's your peer. This is the peer review form I was talking about. So this here is sort of the template that you'll use for your written report evaluation of someone else. So you have your name, whatever paper you select on Canvas, you'll write the project title of that, and then you'll start writing out your report. I also have more formatting guidelines written in the actual assignment details too, and those will unlock after the projects are submitted. All right, now lastly, you have the presentation evaluation form. So the last couple of classes of this semester will be when everyone presents, all the on-campus students present their projects. So you'll all be required to fill out this form for each team, and where you give them an evaluation on how they performed in certain areas. So was their presentation logically organized and easy to understand? Were they clear in their expression? Were they enthusiastic, or were they really boring? So you're going to go through and you're going to evaluate all of your all of your peers, and anyone who gives everyone a perfect score will have their feedback grade penalized. So be like serious in your evaluations, and then be sure to include at least 1 to 2 suggestions for improvement on the presentation. So that's what I recommend you do, is before the presentations actually start, download this form and start filling it out as you're watching the presentation, as you're paying attention. I think that's, or just fill it out at the very end, maybe during the Q&A session, so you kind of remember what each team did, what they talked about, so you can get a head start on that. So that's, yeah, and there's 15 teams here, but we don't have that many teams this time around. We have, I think 6. So that's the feedback portion of the assignment, and then they're graded on the length, making sure that I think the written report has like a 1-page maximum. So if you go over that page, you can lose some points. Making sure, if you just write a feedback report, it's like, hey, I thought this report was great. I have no further comment. You're obviously going to get penalized for that. So attention to details, the clarity of your own feedback writing, and then obviously on-time submission, which I believe it's due before the start of the very last class, so that Wednesday at 10:40. All right, so that is the overall gist of the report, the presentation, and the feedback assignment. I know there's only 5 of you guys here today because of the rain, but any questions on the project, whether that be the written report, the presentation, the feedback assignment? Any questions, comments? Okay, seems like nothing. All right. Again, your next checkpoint assignment, I believe, is 2 weeks from today. Homework 3 will be posted as soon as this lecture ends at 11:30. That'll be due a week from today as well. So next Wednesday, you'll have your homework 3 due, which should be the last and final homework assignment of the semester. Make sure you turn that in on time. And again, follow the formatting instructions in the syllabus. We do take points off of that, and we take that seriously. You write your name in the top left-hand corner instead of the top right-hand corner, we take points off for that. So read the syllabus, follow the formatting instructions. Most of you guys, I think, are off to a solid start. Again, like I said, don't hesitate to expand or contract your scope depending on how you think you're able to reach your 6-page requirement. 5 minutes left. All right, I think that's it for the presentation. Let's spend these last 5 minutes talking a little bit about your exam, I guess. So, all right, so again, she has not written the exam yet. Oh, actually, you know what? Before I'm going to pivot away from that for now. I want to show you real quick an example report that I believe Dr. Greens wanted to show you guys. Okay, so I'm not going to scroll up because I'm not supposed to disclose the names of the students. I forgot to black that out. But just this is, I'll tell you, this was my report when I submitted the report for this class 2 years ago. So mine was on electrohydraulic forming. So here we have the brief abstract where I talk about, okay, what is the process, how does it work? It uses an underwater electrical discharge to basically cause a small explosion to propel material into a die. So it's a forming process. Primarily used on sheet metal, very common in the automotive industry. Increased formability due to a very high strain rate. It's relatively energy efficient and allows you to complete complex geometries using a series of explosions. So here we have a schematic of the process. So the way that our paper was structured, we had the introduction section, processing principle, and then within our processing principle, we had equipment as a subsection of that. So we sort of did what I mentioned where we kind of combined the sections together. So processing principle is sort of the overarching section, and then specifically, okay, we'll talk about the equipment, then we talk about the procedures of how it actually works. Here you can see pictures of the equipment, a diagram of how it worked, control parameters, so like how does the voltage of your diodes affect the performance. So control parameters, here we have a graph showcasing like the effects of those parameters. And then we talk about applications. So what kind of different materials can you use this process with? Obviously you don't want to use it on something that'll rust because you have to submerge your workpiece underwater. What kind of geometries can be created with it? Here we have some examples. So this is an automotive panel, some perfume bottle caps, and then we have a section on the current state of EHF. So we talk about the current advantages of the technology, the disadvantages, and then advancements that are being made currently to try to further improve this process and add more functionality to it. Again, lots of figures. Then we have a conclusion, which is basically, the summary was our conclusion. And then we have our references, and we used 19 references. I think, yeah, DOI. Yeah, I think all of ours might have been scholarly too. Although this one was this might be a patent. I think this was a patent, which is still scholarly. So yeah, that's just a quick little preview of a successful report. I did receive a good grade on this, so it's not like I'm showing you a bad example, so don't worry about that. All right, so that's all I want to talk about with the report. We still have about a minute and a half left, so I'll talk a little bit about what to expect on your midterm exam as well as your final exam. So it'll be a mix of short answer questions with some longer extended response questions. As you should already hopefully be aware, this class is a very conceptual class. There's not a lot of math in it. We're not going to ask you to solve equations or to model any of your processes. So it's going to be very conceptual in nature, so you'll have to kind of memorize a lot of things with this class as a result of that. So you should be able to answer conceptual questions. There'll be a lot of like fill-in-the-blank questions. So like one common question might be like, okay, with abrasive water jet machining, what is the most common type of abrasive that is used? And you'll have to fill in, have to write that in. It won't be multiple choice. It'll be like just a free response right in your answer. You might have some multiple choice questions, some matching questions. Remember the ultrasonic machining diagram where she showed you like what happens if your abrasive is too hard or too soft or just right. So you might have to like match up those cases with the 3 different diagrams. Definitely study your quizzes that she posts. She likes to take questions from that, so that's a good study source there. So go back and study your quizzes, study your homeworks. She'll often either take a question straight from it or maybe reword a question from one of those. So that's kind of like the first half of your exam is those conceptual questions, those short response conceptual questions, and then you'll have some more longer and extended responses. You'll have like, okay, discuss 2 advantages of ultrasonic machining, and you'll have to list two advantages off the top of your head. There might be one where it's, okay, now list 2 disadvantages of this process. Summarize the differences between maybe abrasive water jet machining and ice jet machining. You'll have questions like that where you have to write out and explain and describe the certain features of a process. And then towards the end, you'll also have a question where it'll ask you to, it'll give you a specific case of an application, like, okay, here's like a part drawing that is going to be made out of this material. Select one non-traditional manufacturing process that you would recommend be used to make this part. And then you'll have to describe with a diagram, so you'll have to be able to draw processing diagrams and explain the processing principles behind that process, and then explain why you selected that process for this part and why you think it would work well. So that's a question where there might be multiple processes that could work. There might be some that might be a question where only one of the processes that you've learned so far work for that. So it's a very open-ended question, and the point is to make sure that you guys are understanding what we're teaching you guys, not just memorizing facts, but knowing how to actually apply these technologies and knowing what would work well. So that's sort of a general overview of what kind of questions to expect for the exam. I think we're about out of time right now, so we're going to wrap up the lecture here today. On Friday, I'm going to talk about magnetic field-assisted finishing, which is the specialty of Dr. Green's laboratory that I'm involved with. So I know a good deal about that. It's a non-traditional manufacturing process, obviously. If you guys have any questions on the report or the exam, feel free to come up after class and ask me, or feel free to shoot me an email. Again, my office hours are Tuesday and Thursday. So on Thursday, I'll have office hours from 2 to 3 p.m. Dr. Greenslet, her office hours are on the syllabus, but she's canceled them this week because she's overseeing in Paris. So if you have any questions, stop by my office hours or send me an email. All right, thanks, guys.